As we talk about solutions, solubility is going to be an important concept. So solubility indicates the amount of solute that can be dissolved in a solvent. So saturated solutions cannot hold any additional solute. So a saturated solution is a lot like a saturated towel. A saturated towel can't hold any more water. A saturated solution can't hold any more solute. And you will see the solute on the bottom of the container if you add any more. So this is a saturated, so this solution down here is saturated. That's our saturated solution. Unsaturated solutions can dissolve additional solute, and this would be an unsaturated solution. Presumably we can dissolve a little more in that one. So at 40 degrees, and we'll find that these are temperature dependent, so they'll give us a temperature. At 40 degrees, the solubility of potassium bromide is 80 grams in 100 grams of water. Identify the following solutions as either saturated or unsaturated and explain. So this first one, we've got 60 grams of potassium bromide, and it is in 100 grams of water. Well, we know that we can dissolve 80 grams, so this one is unsaturated. 200 grams of our potassium bromide in 200 grams of water. Well, we need it to look like this one up here. So we'll need to use ratios. At 100 grams of water, well, to get from 200 to 100, we had to divide by 2. So we need whatever we do to the bottom, we'll do to the top. We'll divide the 200 by 2 and also get 100 grams. And then we can compare it to our given, which was 80 grams over 100. So this has got too much potassium bromide. This will be saturated. What if we add 25 grams of our potassium bromide in 50 grams of water? Again, we're going to need to get this in the same form as originally given to us, 80 and 100. So we will get 100 grams of water. We'll have to multiply by 2 to do that. Whatever we do to the top, we'll do to the bottom. Or, I'm sorry, whatever we do to the bottom, we'll do to the top. So 50 grams in 100. Well, we know we can dissolve 80 grams in 100, so this is also unsaturated. Okay, how does temperature affect solubility? Well, if we're dissolving solids in liquids, increasing the temperature will increase the solubility. If you're trying to get sugar to dissolve in your iced tea, if you warm your iced tea, more sugar will dissolve. If you're dissolving a gas in a liquid, it's just the reverse. Increasing the temperature decreases the solubility. So if I'm having a Diet Coke, I have CO2 dissolved in my water, I will cool it first before I open, and that will keep more bubbles in my water. The other thing to note about this is that increasing the temperature decreases the solubility, and this has an impact environmentally. When we have power plants that discharge warm water holds less oxygen, and you can get large fish kills if we don't have enough oxygen in the water. Okay, so some things, we have some solubility rules. These are just, you don't need to memorize them, but you will need to be able to apply them. It's important to note that a compound is soluble in water if it contains one of the followings. If check first, its positive ion. If it has lithium, sodium, potassium, rubidium, cesium, that's the first column of the periodic table basically, or ammonia, it will be soluble. If it has, for negative ions, if it has nitrate or an acetate ion, it will be soluble. In general, you'll find the halogens are soluble, that is, chloride, bromide, and iodine, except when combined with silver, lead, and mercury. This one right here. Sulfate is soluble except when combined with, there's a whole list of ions here. You just have to check them. Soluble ionic compounds that do not contain at least one of these are going to be insoluble. So if you don't see it on this list, it's probably insoluble. And you can write it down as insoluble. So let's use the table and predict whether the following compounds are soluble. Well, first we have sodium phosphate. Sodium is right here. I'm going to, on our table, and so this will be soluble. Calcium carbonate. Well, calcium is not one of the positive ions mentioned here. So then we need to check our negative ions and see if carbonate is any of them. And we do not have carbonate on our list. So we will list this as being insoluble. Potassium sulfide. Well, potassium is right here, and so we will list this as soluble. Calcium nitrate. There is no calcium, we're doing this one now, calcium under our list here, but nitrate is right here. Let's get a different color. And so it will also be soluble. Lead chloride. So lead is not mentioned under any of these positives. So let's look for chloride. Chloride is mentioned right here. So chloride is soluble except when combined with lead. So this will be insoluble. Let's look at aluminum phosphate. Let's get color, aluminum phosphate here. Aluminum is not mentioned as one of our positive ions, and phosphate is not mentioned as any of our negative ions, so we'll say that this is insoluble because we didn't find it anywhere. And sodium hydroxide. Sodium is one of our ions that's mentioned as being soluble, so we'll expect this compound to be soluble. Okay. So let's see what happens to solubility when we pour solutions together. So if we add a solution of sodium chloride, which we know is soluble because it's got sodium in it, and silver nitrate, and we know that all of the nitrates are soluble, we'll get a bunch of ions. So the sodium will dissolve into positively charged ions, and we'll put aqueous beside it. plus chloride ions, which will be negatively charged, and we'll put aqueous beside that. The silver will form a charge, positive charge, and the nitrate will form a negative cation. So what's going to happen here is we're going to have two possibilities. The sodium cannot combine with the chloride because it's already started with the chloride. It needs to combine with something negative, so it will combine with the nitrate. And we'll get the possibility of making sodium nitrate. Our other possibility will be that the silver will combine with the chloride. Let's see, so it'll be silver chloride. Now if we look at sodium nitrate, we'll see that it's going to be soluble. Sodium is here, nitrate is here, so it's a double soluble. So this is going to stay aqueous. It's actually going to stay in its ions. It's going to be sodium ions and nitrate ions because it's soluble. But let's look and see what happens to the silver chloride. Chloride up here is soluble except when combined with silver. And so the silver chloride will be a solid and will appear as a precipitant. So let's see what happens when we mix ammonium chloride and calcium nitrate together. We'll get ammonium ions and chloride ions and calcium ions and 2 nitrate ions. The ammonium that's positively charged can react with the nitrate. So we get ammonium, nitrate. Notice when I draw these compounds, all the charges have disappeared because they're neutralized. One positive, one negative. The other thing that can happen is the calcium that's positively charged can combine with the chloride. Always write the positive one first. And we'll have 2 chlorides for every 1 calcium so that we get a neutral compound, no charges. So let's look at these and see if they're soluble. We've got ammonium nitrate. Well, ammonium is right up here and nitrate is right up here. So this will definitely be soluble. So we'll put aqueous beside that. Calcium chloride. Calcium is right here and it is soluble except when combined with silver, lead, or mercury. So this is also aqueous. So this reaction will not happen. We'll just end up with these ions. Okay, lead nitrate will form a positive lead ion plus 2 nitrates. Those of you who are paying attention will notice I'm not paying too much attention to balancing these reactions. Potassium ion and chloride ion. So let's see what we can make. This positive can come down here and react to make a compound with the negative. So we'll get lead and we'll need 2 chlorides. And then the potassium can react with the nitrate. And then we need to look up here and see if these things are soluble or not. Potassium is right here, and nitrate is here, so that's doubly soluble. So we'll put aqueous, that's not going to be a precipitant. Chloride is right here. And it's soluble except when combined with lead. So this is going to be a solid and will precipitate out of solution.